So, welcome everyone. My name is Felipe, and I will be your host for today's webinar on getting the most out of ScyllaDB. So, in this webinar, we will cover many important aspects and considerations tied to an actual ScyllaDB deployment. We have collected, me and Lucas, my partner here, we have collected several mistakes, and some of those mistakes may not be necessarily apparent at first glance, but those mistakes are fairly often commonly overlooked optimizations and are mistakes that users make when they are working with ScyllaDB. So whether you are just getting started or if you are already a ScyllaDB expert, we expect to have relevant information for you today. And by the end of today's webinar, you should be ready to take your ScyllaDB deployments to the next level when it comes down to high performance and low latencies. So a quick intro about ScyllaDB. For those of you who are not familiar with ScyllaDB yet, it is the database behind game changers. Organizations whose success depends upon delivering engaging experiences with impressive speed. ScyllaDB was built with a close-to-the-metal design that squeezes every possible ounce of performance out of modern infrastructure. This translates to predictable low latency, even at high throughputs. And with such consistent innovation, the adoption of our database technology has grown to over 400 key players worldwide. Now, many of you will recognize some of the companies pictured here. For example, we have Starbucks, who leveraged ScyllaDB for inventory management. We also have Zillow for real-time property listing and updates. And we also have Discord, who is connecting several users in real time all around the globe. So as it can be seen, use case. But it probably has a use case that is a perfect fit for ScyllaDB, and it may be that you just don't know it yet. I think I had an issue with my microphone, right?
Yeah, I think you did. You know, I was not hearing you, and since it started raining here, live things that does happens, I didn't know it was on my end. Sorry.
Well, that's the perfect time for an intro. So I will hand over to you fairly quickly, Lucas. So I am Felipe Mendes, and I work as a solution architect here at ScyllaDB. And my main role is to work closely with users during their ScyllaDB journey, gather requirements, offer technical consultation, and ensure that ScyllaDB is the right solution for your needs. And partnering with me today, there's Lucas. And Lucas, do you mind introduce yourself, please?
Hi, my name is Lucas. I'm a customer success manager here at ScyllaDB. And, you know, I have been shared my experience working with IT in general and databases between manageable roles and more technician, hands dirty side work, which I love it. And so, you know, when this opportunity was presented for me and Felipe, that we have worked in several projects before, to talk a little bit about how awesome ScyllaDB is, I jumped right in.
Thank you. Perfect. Yeah. And I'm quite certain that today you are going to share your real life experiences around how to use ScyllaDB and most of the mistakes you see on the field. So it turns out, guys, that today we have a lot to discuss. And here's just a summary of a quick overview of what we've put together for today. So this is how this is going to work. Me and Lucas, we are going to have a very good chat where we are going to share our experiences and advices around this broad array of topics that you see over here. Starting from what to do if you are just getting to know about what the ScyllaDB thing is, how do you actually run it on production, what are the most important client-side settings you need to be aware of, and so on. All right, so let's start with the basics. And Lucas, that's my first question to you. We already know that ScyllaDB is the database for data-intensive types of applications. So we have this awesome shard per core, shard notching architecture, which is oriented for performance and all that. But what if I am just getting started? I mean, what would be your recommendation for someone who is still in that process? You know, hey, does this database, this ScyllaDB thing, even works for me? What would be your recommendation in this case?
Felipe, that's a great starting topic. So, as you know, one of the aspects that I like most about Scylla is how fast and easy it is to actually start playing with it. If you're in the earlier stages experimenting our solution, then you should definitely go through the Docker route. It makes very little sense for you to spin up a cluster on your own or even ScyllaDB cluster, as you're very likely to need to work your data modeling, connect your application, understand your database fundamentals, and many other aspects that are tied to everyone's learning curve. So you don't need to create like a full-blown Docker cluster in order to get started. In fact, I think spinning 3 containers on your own laptop is kind of pointless for some reasons. First, because ScyllaDB is very resource intensive, when you spin your first container, chances are that you start hearing your laptop's fans spinning like crazy. And due to the CPU temperature increasing, and naturally that worsens if you have 3 containers. Second, the chances are that you won't need or should not expect good performance, high availability, or any faulty tolerance setup at this stage. After all, you're running on your desktop. And third, learning a new technology always takes some time, and you definitely don't need to have a 3-node cluster running locally for a long period of time when you're barely going to use it. As a result of those, get started with Docker, but run a single container. Unless you're actually planning to become a ScyllaDB administrator and manage your cluster by yourself, use the single container to learn about how the data modeling aspects are for that specific database, how to connect your application, and once you feel comfortable, and only then, the results are okay, then you shift your deployment to a proper production-grade environment. With all that said, there are some situations where you might want to spin a full-blown environment, perhaps even a multi-data center one, if that's the use case you're going to be using. For example, you may want to test ScyllaDB high availability, or you want to check whether your application failover logic is correct. Perhaps you want to learn more about all the different consistency levels that exist. If that's the case, then the good news is that you may configure ScyllaDB to become less resource intensive and still run flawless on your laptop. The ScyllaDB Docker image in Docker Hub contains a very extensive list of parameters that you can pass when spinning your nodes to relieve the performance impact of them. For example, you may control the number of CPUs and memory each container will be allowed to allocate. And that's very important. Specify whether you're running it over a provision environment, whether you want to enable the developer mode and relax some runtime checks, etc. If you're running on the process, developer mode is great because you can bypass a lot of checks and make sure that things run smoother. And of course, there are more limits and restrictions that you can add to your database. And the more you do, the less performatic will be. But at this stage, this shouldn't be your key point and shouldn't really matter. I know that I spoken extensively about containers, and you might get the wrong idea that they are unsuitable for production purposes. Felipe, this brings me to one question that I want to shoot at you right now. What are the top recommendations when it comes down moving your workloads to the next step? So you're ready, set up your environment, see how it works, learn, the basics about data modeling, connection, and etc. And now you want to move to the next step. Are containers even suitable for a thing like that?
Whoa, that was a great question, buddy. Thank you. A great answer, actually. Thank you. And a great question. You know what? When you mentioned about the fans spinning, I was like, oh, that's so true. I recall when I first started with ScyllaDB, I naively said, okay, let's see if that string is fast. And then all of a sudden I started hearing my fan spinning like crazy. And I was like, whoa, yeah, okay. that Chingy know how to perform well. But yeah, I mean, as for your question, I mean, I think it's time for us to talk about deployment types, right? So let's do that. And allow me to follow up, get started, starting from your last question around containers. So one of the known problems with containers is that by default, they do add another layer of overhead, which ends up hurting performance. In particular, we have in the past written a very good article called The Cost of Containerization, where we show off how a ScyllaDB instance running directly on top of AWS EC2 can deliver around 3x, that's 3x, 3 times the throughput under lower latencies when compared to a container deployment under stock settings. That said, containers are not necessarily evil as long as you know what you're doing. We do have several users running ScyllaDB on top of Kubernetes, and as long as you follow the best practices there, you are very likely to still hit a performance penalty. But what's essentially going to happen is that this performance penalty is going to be alleviated by a lot. According to our benchmarks, Kubernetes deployment would perform upwards 1 or 2% compared to a bare metal or a suitable cloud instance. So it's not that much in the end. Now, if you do decide to go the container route for your production environment, then you should definitely use our Kubernetes operator. And the reason is quite simple. The operator includes all the logic and all the automation behind it to orchestrate a ScyllaDB cluster as a stateful set. However, one thing that very few people actually do, and they should, so if you are running ScyllaDB in Kubernetes today and you are not doing that, you should do that, is to actually run the necessary tuning and the optimizations which are available as a customer source definition. So in our operator or Kubernetes operator, we have this node config CRD, which you can easily configure to tune your ScyllaDB nodes, your ScyllaDB pods to perform as they should under the hardware you're running on. Now, unfortunately, we don't have the time today to go through all the Kubernetes operator details, but in general, the most performant deployment will be one where each node is located on its own virtual machine, and you are going to expose the host network to each pod, as well as apply the optimizations I mentioned earlier. Okay, so that's for Kubernetes. Now, regardless if you intend to run on top of containers or not, remember that ScyllaDB is a database oriented for performance. And this is where I'm going to address the second part of your question. So when should you actually be moving your workload to somewhere else after, okay, I started playing with this on my laptop, I see things are working and I'm ready to move to the next stage. So by the time you realize that you've hit a wall where you are unable to scale any further, or your latencies start deviating from what you would normally expect, that's the moment when it's time to switch to a proper production environment. So although running ScyllaDB on your laptop is very convenient and you should be able to get a decent amount of throughput out of the box, and just as an example, on my MacBook Pro, I can easily reach and sustain 40,000 operations per second. Nonetheless, there will come a point when things are inevitably going to start to break, right? And this brings me to the first part of your question, which was around the top recommendations that I have. Well, the easiest and fastest way for you to move to get started on production is to use ScyllaDB Cloud. And for ScyllaDB Cloud, we have this very nice calculator where you are simply going to input your target throughput, your expected dataset size, and in the end, it will advise you which kind of deployment you need, okay? If you can't use ScyllaDB Cloud, or if you don't want to go through the managed service route, then that means that essentially you will be managing your own deployment. And my recommendation is that you look after storage optimized instances as available in most cloud providers, such as AWS i4is or and i3 EMs type of instances, GCP N2 Hyman with local SSGs, or Azure LSV3 instance types. All right. Now, a heads up for you. Note that I particularly highlighted storage optimized instances, because those instances are the ones which come with NVMe SSDs attached to them. ScyllaDB is fairly often used for very latency sensitive types of workloads. And even production grade NVMe disk nowadays has a latency of around 20 microseconds, which, if we stop and think, is fairly slow when compared to a CPU cache of a few nanoseconds per instruction, right? All that said, avoid using slow storage mediums such as EBS disks unless your workload can tolerate some level of latency variability. And if you still decide to go against these recommendations, then that means if you decide to run your database on top of network attached disks, then ensure that you place a dedicated disk to your commit log directory, because that will ensure that your commit log writes will not compete with the compaction workload that happens in the background. Okay? Now, ScyllaDB supports very versatile deployment types. We have customers running ScyllaDB on top of spot instances and even on top of hard disks, okay? But it is important for us to remember that given that we have a close to the metal architecture, the performance that you will get in the end will depend on how performant the hardware you throw at ScyllaDB is. Just for me to wrap up, and I know I'm talking for a very long time, so last point, and I promise I will switch back to you. I could probably spend an entire webinar talking about all the infrastructure components that you should keep an eye on. Luckily, I don't have to, because we have recently started this blog series, which is currently focused on infrastructure, where I pretty much explain everything you should be aware of prior to making a decision for your production workloads. All right, so let's switch to the client side of things, because I need to drink some soda. And before I do, Lucas, I just spoke about the ScyllaDB core specifics. So what about the client side? And how can an engineer, a developer, take advantage of the ScyllaDB powerful architecture?
Well, just like you mentioned, you could spend hours talking about a subject. I definitely could spend hours talking about this, because this relates to most day-to-day activities that we have to deal with. But most people unfortunately neglect the importance of the client side and may either introduce database allocation problems or simply cause their clients to be the bottleneck. So starting with the basics, after you set up your cluster, be sure to collocate your application close to your database. By doing so, you avoid extensive network round trips, which are very harmful for latency. Just like Felipe mentioned, the disks cannot be a bottleneck, network cannot be either. Also, ensure that your clients run on top of a sufficient powerful hardware. Again, I'm stressing out what Felipe already said. These don't have to be as beefy as your database nodes, but should have enough resources to handle all the processing, network traffic, memory footprint required by your application. And this is particularly important when your application gets a throughput intensive, when you pass over like 100,000 operations per second. Now that you've probably seen, ScyllaDB supports several drivers in a variety of languages. So which one should you choose? In general, the most efficient drivers are the Rust, Go, C++, and Java drivers, although in general, it shouldn't matter which language you choose, but which driver flavor you choose. Let me explain. There are two types of drivers, shardware and non-shardware ones. So shardware drivers leverage Scilla shard per core capabilities and will open one connection to every single shard or CPU that exists to your target cluster. Non-shardware ones don't contain that logic, and therefore requests may get routed to different shards, requiring cross-CPU communication, which, due to that, can be slightly detrimental to latencies. If you're using a non-shardware driver, you must always ensure that you open enough connections to your cluster to ensure that every CPU receives at least a single connection. For example, if your nodes have 8 shards each and you want to configure your clients to open at least 8 connections per node, this is not a requirement for the shardware drivers, as the logic is already built in as a part of the driver logic. There are definitely other important tuning settings you want to ensure your clients make use of, such as paging, making use of the proper load balancing policy, avoiding running extensive cross-data center queries, making use of prepared statements, and etc. We have a very good article on how to optimize your SQL queries, which you should refer to in order to understand the nuances and do's and don'ts related to the driver configuration. And before we move to the next topic, because I know Felipe is eager to talk already, it's important for me to talk about one of the most common mistakes people make when using ScyllaDB. They don't impose any concurrency limits on their application. Let me go into that. Most databases have a hard-coded concurrency limits and will throttle down your requests once you hit past certain limit. However, because ScyllaDB workload latencies are very flexible to your needs, we don't impose any concurrency limits other than protecting the database stability itself. With that said, it's really important to control your client-side concurrency, and we have several articles on how to do that. For example, earlier this year, Optimizely shared how they maximized their ScyllaDB concurrency by applying control theory algorithms and follow the universal scalability law. Most recently, we've shared a nice blog posting on some ScyllaDB capabilities that you can use to configure your database to shed requests past a certain limit. So, Felipe, let's move on to our next agenda now.
You know, that concurrency kind of thing, that's so true, buddy. I think that's one of the problems we primarily see on the field, right? I mean, everything is working nicely, and then there is this sudden spike of requests, and hey, guys, my latencies are running out of control, and then we go to the monitoring and say, yeah, you have unbounded concurrency on your client application.
Yeah, you know, and that could be maybe a twofold. Maybe, you know, people are not familiar with ScyllaDB, or they come from a different background, you know, working with databases and are already somewhat spoiled, get, you know, that a hard limit set on. So it is true, you know, that's one of the common items that we have. Luckily, it's easy to, you know, fix, but that's why we're bringing on this presentation here as well. And, you know, don't think you're going to escape me now, because I want to know from you how critical it is to get your data modeling correct for a data intensive workload. Since we're talking about that specifically, how do you get it right?
Well, yeah, definitely.
And how critical it is.
A lot critical. Yeah. So, good question. So it turns out that for database like ScyllaDB, well, actually, guys, that's for any database, actually. Getting your data modeling wrong is definitely the easiest way for you to undermine your performance altogether. So imagine, even if you're coming from a relational type of database, it's very easy for us to imagine some well-known winch patterns that you can run, which are probably going to introduce a performance bottleneck. And ScyllaDB as a database is no different. So I recently presented, I think it was last quarter, we had the data modeling masterclass, and that alone was another 40-minute talk. But the information I have for you is if you are just getting started, then you should definitely learn the foundation of NoSQL data modeling before you actually watch my session, because my session was a bit over the next step after you are already used to the fundamentals. And for that, we do have ScyllaDB University, which is a great resource to get started. And if you are past the fundamentals, but feel like you need a quick recap, we also have another very good blog, which is the best practices for data modeling. I mean, you should be pretty much referencing that article as you progress and as you learn more about ScyllaDB and NoSQL in general. Because we try, in general, all those researches I just spoke about, masterclass, ScyllaDB University, and this last blog, even though we do use ScyllaDB as an example, those the aspects that we cover will be pretty much be useful for any type of NoSQL database. All right, so consider them to those researches to be your North Star. But to answer the question and not just shout out some links for you, the overall idea of data modeling is that you should model your queries to fulfill your application query needs. And that notion, that mindset change directly contrasts to how data modeling is done in relational databases. And in particular, I really like an example that John Haddad provided in our most recent migration masterclass, where he explained that given that NoSQL databases are oriented for performance, it makes little sense for you to try to join, two tables with 1 billion records each and expect it to actually be run in a performant way. That's simply impossible, because what you are trying to do, join 1 billion records from table A with 1 billion records from table B and expect this operation to complete in a few milliseconds, is just beyond what existing computers can do, and even physics nowadays. So you are better off if you are trying to solve a problem like that. The key is the normalization. So learn about the NoSQL data modeling needs, and consider rethinking your domain data-driven design and your application query needs. All right. So this may typically take a long time of study and analyzing, understanding how your application, your use case works. It's easier said than done, actually. But let's talk about some of the best practices. So, particularly using ScyllaDB as an example. First, a proper selection of your primary keys. That's truly crucial because it helps you to avoid imbalances and ensure that you fully utilize your cluster as a whole, rather than you end up introducing performance bottlenecks to a few replicas. And this is perhaps the most important recommendation I can give us, since ScyllaDB is a distributed database, and that's important, guys. That's distributed system theory. For whatever distributed system you work on your life, whether it's a database or not, the speed of that system is always going to be tied to the speed of its lowest replica. Okay, so the less imbalances you have, the better you can fully utilize your resources, and you can avoid having a slower replica, which slows down everything. The second recommendation is tied to the previous one, which is to avoid hot access patterns, such as hot partitions, which similarly cause an imbalance to how data gets accessed into your cluster. Here, I want to highlight that a few access imbalances are normal, and ScyllaDB in that regard comes with a specialized cache to ensure that when your application is always querying hot items, those items are served efficiently from our cache. But even though we have all those goodies that help with lower latencies, you still should not abuse from it, and you should not cause what we call the hot partition effect, which is when your application is blasting a single key nonstop, because in the end it may undermine your latencies in the long run. The next recommendation that I have is, of course, also tied to the previous one, ensure that your partitions, your rows, your cells are seemingly evenly distributed, because as you are scanning through, because when your application needs to scan through large items, it will require more time for the data to be transferred over the network back to your client application. And this may increase your latencies. So large partitions, large cells, large collections, large items in general are typically not recommended to do it for that reason. The time it may take for you to read the data, the database to find it, start sending it back to your client, and the time it takes to arrive, which is highly dictated by the network speed and paging, etc., and so on. All right. Not to mention the fact that large items will typically require more memory allocation from the database, which may cause allocation issues. All right. Data type wise, when you're doing your data modeling, be very careful with collections, because I think Lucas here will probably agree with my comment, but we see a lot of people making wrong use of collections. And really, if you don't know the data type you're using, how it works under the hood, and this is covered in my masterclass talk, that's essentially the easiest way for you to see your latencies going from 1 millisecond to 2 seconds, like in a blink of an eye. All right. And last but not least, we do have to talk about tombstones. So if you have potentially a delete-heavy workload, I highly recommend you to understand the impact that your delete may have on your read path. And for databases like ScyllaDB, you have the flexibility to adjust your compaction strategy accordingly. All right. As an example to that, you may be interested on how Level Infinite, which is a subsidiary of Tencent Games, implemented a durable queue-like type of use case, very delete heavy on top of ScyllaDB without any performance issues. All right. And well, that's a lot of recommendations. I hope you guys got it all, but I think this pretty much sums it up. And okay, once again, I spoke a lot. Sorry about that. And let's switch over to our next topic, which is resiliency. And turn back to you, Lucas. And my question for you is essentially going to be, we have some people who eventually ask if it's okay to run ScyllaDB on top of a single node, or whether is it fine to run it on top of 2 nodes, or they have trouble trying to figure out their replication factor, etc. What's your take on how a ScyllaDB cluster should be assembled to have a resilient and reliable ScyllaDB deployment?
Now you're tossing me an easy one. So that's simply put, our recommendation that you run at least a 3-node cluster, and there are quite a few reasons for that. First, ScyllaDB consistency model allows you to have tunable consistency. The only way to achieve quorum is to have at least 2 replicas available. With a 3-node cluster, you can therefore survive the loss of a single node without the impact of running operations. And of course, if you have a less strict consistency requirements, you can probably run Scylla with 2 nodes, but you definitely should not be running a single node deployment unless you're working with some sort of embedded device. For example, We have some companies leveraging our DynamoDB API to support the healthcare services on IDT inside the hospitals. So basically, that's going to be running inside an application, inside a device. And in that case specifically, that's totally okay. But we're thinking from a high availability perspective. You should always consider running your deployment across multiple availability zones. If you're in the cloud, or ensuring that your infrastructure is physically separated when you are on-prem, those are very important. So high availability is one of the hot topics and basically one of the main reasons that we're going to be choosing Scylla. Here again, the reasons are very simple. By doing so, you ensure that your deployment is able to survive a zonal outage, an infrastructure failure, and you're still going to have zero impact to your applications. While this is true that replicating data to other availability zones is more expensive in terms of network traffic, that's sometimes a price that you have to pay to guarantee the high availability. Nonetheless, ScyllaDB recently started supporting a driver load balancing policy called RAC, or zone aware, which allows the client to route the traffic only to replicas located in a specific availability zone. Thus, that reduces a lot of the network traffic bills. This is available, for instance, in our Rust and GoSQL drivers already. The last aspect that I want to touch is related to the resiliency drawdowns on your replication strategies. There are two types of replication strategies that you will likely use when working with ScyllaDB: simple strategy and network topology strategy. In general, you should never, and I will stress that, never use simple strategy for production workloads. This strategy does not take into consideration the placement of your nodes, which means that your data could be replicated to replicas located in a single availability zone. To understand why this is bad, let's consider the following example. You have a 6-node cluster with 2 nodes per availability zone. That's the default. Oh, you're just confirming what I'm saying. All right. Okay. So you want, yeah, I just, for a second, I thought I said something wrong, but you have a 6-node cluster with 2 nodes per availability zone, and you want a replication factor of 3, which means that your data should exist in at least 3 nodes. If you use simple strategy, ScyllaDB can naively replicate your data to 2 nodes located under the same availability zone. And if that availability zone goes down, so will your availability. Another drawback of the simple strategy is the fact that it's also not DC aware. So it can replicate data to other data centers. And when you read the data, you may need to go through a very expensive cross data center network hop, undermining your latencies. Unlike simple strategy, the network topology strategy does take into consideration your node placement and will prevent that all these previous examples that I mentioned from happening. Do note that the procedure to switch from simple strategy to network topology strategy can be burdensome, and depending on how your cluster topology, it may even introduce an outage. Therefore, avoid running the mistake of choosing simple strategy for your production environments. And Felipe, you had asked me before, this is another thing that we commonly see on the field, Somebody starts, do their test, use the simple strategy because it's fine on their, only homebrew environment, single computer or single node. And then when they move to a multi-DC, especially, that can becomes a huge problem. ScyllaDB is an always-on database run by several companies for their mission-critical workloads. And if that's the case, these recommendations are the foundational reliability aspects of working with your database. Let's go over to the next topic, Felipe.
Let's go.
Okay,
what is it?
So I have a question for you. I'm not gonna get easy. So what are the observability options in ScyllaDB? What does a typical troubleshooting look like? I'm asking you because I know the answer, but I want to know if you do.
Damn. So, well, what does a typical troubleshooting look like? Well, you know what? It's
there is no such thing.
Yeah, it's unfortunate, but we do have to tell you that, unlike what other companies try to sell you, that they have the perfect solution that never breaks, there will come a time when you may need to troubleshoot issues. I mean, it's part of life, right? And this is going to happen even in our rock solid database. So observability is actually a very nice topic because most people typically confuse it with just monitoring. And really, guys, monitoring is just a small portion of a much larger ecosystem built on top of your infrastructure. But yes, we do provide a monitoring solution called the ScyllaDB monitoring stack, which is open source and it's free and it's based on top of Grafana and Prometheus. But if we were to limit our talk just to our monitoring, that would be a huge mistake. And once again, last year, I had a chance to partner with Dynatrace and Grafana Labs in our recent observability masterclass. And what I want you guys to learn here today is that one of the aspects that I learned and really caught my attention was the talk around the three pillars of observability: metrics, logs, and traces. Those three aspects are really important for you because when a problem happens, you will typically need to rely on those three things to know what's wrong. So when things go wrong, we will typically ask you to upload us your monitoring metrics as well as your cluster logs in order for us to reason around the problem. As a result, please, we always ensure that you deploy the ScyllaDB monitoring stack, even if you actually don't want to use it, and I don't know, maybe you want to integrate your metrics, your monitoring solution with another one, such as Datadog. That's fine, but please use the ScyllaDB monitoring stack. Speaking of Datadog, I mean, we do have a native integration with Datadog, but it's not as enriched and detailed as the Prometheus-based one, because the Prometheus-based one is our official monitoring. And given that, I could probably tell you a handful of situations where we requested someone to send us their Prometheus data, just to hear later that they don't have it. And this is a bit complicated because, guys, if you don't have monitoring to a distributed system, that essentially means that you are walking half blind. That's the proper definition of it. So there are very little insight that you can get and no ways, to get alerts when things go wrong. Therefore, the ask here is really simple. Take some time to familiarize yourself with the ScyllaDB monitoring stack, configure your own alerts, which makes sense for your use case and for your organization, and then you can integrate it with PagerDuty, Slack, whatever. And I am quite certain that it will help you in the long run. So that's for monitoring, okay? As for logs, ScyllaDB supports several logging facilities, just like, syslog, the syslog protocol, where you can define different levels, such as debug, trace, info, warning, etc., and so on. So, for example, we have a command called node2 set logging level. And this is going to be in the chat in case you never use it, that command in the past. And you can tell the database to increase the verbosity of each specific component, such as the commit log, compactions, how the cache is performing, etc., and so on. So that's really nice because you can increase the verbosity while the database is running. And the last pillar that I said, remember 3 pillars: monitoring, metrics, logs, and traces. The last pillar is tracing, which you will typically use when you want to, analyze your query path if you are suspecting that of an inefficiency with a specific node or a specific shard or a specific partition. For this, when you need to trace, we do provide really a Swiss knife of features such as probabilistic tracing, slow query logging, large partitions, row cells, collections, tables, which you can simply query and retrieve data in real time, as well as many other capabilities which are well beyond the scope of our conversation for today. And you can go to our documentation under the tracing page to learn more about some of those features. Woo! See, observability is really a lot of stuff. And Lucas, I don't know how we are with the time, but let's go to the last topic for today, which is benchmarking. And my question for you is, so we spoke about a lot of stuff today, how to run ScyllaDB in production, a reliable deployment, why data modeling is important, why observability is important, what are the basics. We shared a ton of resources. But okay, so we have just promised to users that they are going to get high throughput and lower latencies against with ScyllaDB against any database. And guys, that's guaranteed as long as you follow what we just said, all the recommendations we just said. Pick your database and put it aside with ScyllaDB, and we should be faster as long as you follow our recommendations. Now, that said, just call for some attention. And people, I hope you guys will try to put us under some load tests. What are your recommendations for benchmarking ScyllaDB? Or benchmarking any database in general?
Well, I would say that whatever you're doing, any sort of benchmarking, you pretty much need to sum up everything that we discussed so far. But the most important aspect is to know and understand which goals you want to achieve. For example, is it possible that you want to compare ScyllaDB against Redis, and Redis may win as an in-memory database, whereas we're not? However, very likely your results are not going to be too far off from each other if you analyze the results from a performance perspective. Similarly, ScyllaDB deployment will likely be more economically viable than your Redis deployment. And sometimes that's one of the most important aspects you have when you're benchmarking something, the economic aspect.
I mean, that's the point, right? I mean, I just ran a benchmarking in Redis. Hey, my P99 latency is 1 millisecond. Oh, with ScyllaDB, it's 2 milliseconds. But ScyllaDB costs half than Redis. So, come on, guys.
Yeah, I avoid getting into numbers, but it's something like that. So you want also ensure that you run your benchmarks at scale, and that's important. So we have seen some people trying to compare ScyllaDB against other databases and showing off results when the database was running inside their own laptops, just like the example I said in the beginning. Let's be honest, unless you plan to run your production workloads on top of your laptop, any benchmark results that you get on this exercise are going to be just a waste of your time. We already spoke about how containers can be evil to performance and how the ScyllaDB architecture is close to the metal. Another reason you want to benchmark at scale is for you to be able to easily visualize how ScyllaDB performs better than the other databases. That is, you run ScyllaDB versus Cassandra, for example, in a small machine. It's very likely Scylla will still perform better, but not to a larger extent. So as soon as you add larger machines, these differences are going to become very, very noticeable, given Cassandra architecture doesn't scale linearly. In fact, one of the reasons why we recommend our users to run on larger machines rather than small machines, also
that's the reason.
Yeah, that's the main reason. If you're running small, you're going to have some differences. They're not going to be much if you're going to bigger machines, and you need to use scalability. And let's face it, that's the reality of most business. That's where you really shine off. So any program is able to bottleneck and make efficient use of resources in a small machine. But when your deployment gets really large, you require the low latencies and the extreme high loads, and that's where the other database falls short if compared to Scylla. Well, these are the main recommendations I can give you in the short time we have. I note that we're short on time, and I would like to extend this subject further. Unfortunately, all things come to an end. So
Yeah.
one very important resource that I would like to share is the do's and don'ts of the benchmarking databases. But that alone is a 45-minute talk. So, take a good look at it.
Yeah, that's
And
a very good talk from Glauber. Yeah. Hmm.
yeah, I love it. It's like
Yeah.
one of the things that I do every year just as a reminder.
You watch Glauber's presentation. Yeah, that's a good practice. Yeah. But yeah, cool. Thank you very much, buddy. And all right. So this brings us to the end of our presentation. And I can't believe, Lucas, we have been speaking for almost 50 minutes now, non-stop. But we hope you enjoyed and that you learned something from me and Lucas today. So we tried to cover a broad range of topics, but the reality, as you realized, is that each one of its own are very likely good candidates for their own dedicated webinars. So for each of the topics we have covered, we provided useful links to other talks, documentation, blog posts, everything you need should be in the chat should you want to learn more and further expand your knowledge. All right. And last but not least, we are providing the following 3 additional resources for you to learn more and get started with ScyllaDB. So go to scylladb.com/cloud and sign up in order to start a free trial. So as we said during the presentation, ScyllaDB Cloud is definitely the easiest and fastest route to get started with ScyllaDB. With a few clicks of a button, you can spin up a cluster and boom, run your workloads and be happy. Next, I would like to invite you to our upcoming ScyllaDB Labs event. And ScyllaDB Labs is really cool because it's all about hands-on, all right? So there you will learn how to get 1 million operations per second from scratch, how you are going to build your own application from ground zero, and how to run your workloads at production scale. And lastly, but no less important, if you care about performance, which you should, since you are attending this talk here today, be sure to register for P99Conf. So P99Conf is a vendor-neutral virtual event which is centered around low latency, high performance design. In this year's P99, we will have some speakers. I don't know, Lucas, if you ever heard about those companies here. Netflix or Meta,
Just a little
TikTok,
bit.
Google, and of course, ScyllaDB. Nice, yeah. I am excited to see you all there on P99Conf. And guys, with all that said, let's see. We have 5 minutes left, so I think we can cover some questions which I see on our QA. Leo is asking, when will the ScyllaDB's mascot be made available? Well, it is made available. Go to Scylla University, fill out, do all the courses, and depending, unless you have a shipping restriction, you should get a swag pack on your house, but you have to complete all the courses, all right? I see also Peter asking several questions. I think you attended our masterclass, right, Peter? We'll follow up on that and we'll let you know. Okay, so one question for me to touch base on. Actually, a good question. So, how accurate is the calculator estimation? Yeah, so we spoke about the ScyllaDB Cloud calculator. And this question is good. Let me see the time because it also requires a long answer and a proper explanation. So how accurate is the calculator? So the result you will receive when you use the ScyllaDB Cloud calculator can either be under provision, just right, or over provision. Why? And that's the part which requires a long answer. So our cloud calculator considers a workload, a mixed workload with perfect data distribution, where a good portion of your reads go to the cache, which would result in fewer round trips to disk. It's important to define that because if your workload is read mostly, with most reads coming from the cache, then you will likely be over provisioned if you follow the calculator output, because the ScyllaDB retrieving data from the cache is much faster than retrieving from disk. On the other hand, if your workload is read mostly, but you have lots of code reads, such as the one which primarily go to disk, then you may find that you will quickly reach your peak I/O performance, because random reads are usually very expensive from the disk perspective. If that's your case, you may require more hardware to further sustain your workload. What else? We also don't account for other features such as indexes, materialized views, CDC, etc., as that would just add more complexity to the calculator. And honestly, it's pretty much impossible for you to make a calculator that's 100% accurate. So we just keep it simple. Other aspects that we consider. We also consider that your workload require a very low, typically single-digit milliseconds latencies, because that's our promise, and it will try to estimate your sizing based on this input. So, in general, guys, there's no magic recipe here, no calculator which can fit whatever workload exists in the world. So each workload is different, every access pattern is different, and the P99 latency requirements vary from one to another, all right? And that's why we ended up with this talk covering benchmarking, which covers pretty much most of what you should be aware of during your testing journey along with us. All right, so we have 1 minute left, and I can see we have tons of questions that we didn't get a chance to get through. And I think that was primarily my fault, but we will get back to you and we will answer as many questions as you want. In the next slide, we have my contact and Lucas' contact. So feel free to email me or Lucas. And with that, we hope you learned something new. Lucas, any last words for the day?
Yeah, it's just that this conversation doesn't need to end here. I know that we shared a lot of information with you guys, and sometimes it's hard to absorb. If you have any questions, you can use the emails, you can talk to us. We have all the links that we shared with you as well. And we have our user Slack as well that you can always communicate with those questions. Either us or somebody else can jump in, even other users, and help you with any questions you might have. But, you know, all in all, it's great to have you guys here, and we really had a good time. I know that Felipe, I'm going to take my share because I do tend to talk a lot. So, you know, hope to see you guys in the next one.
Stay in touch, guys. Yeah.